Hi, my name is Dan Badier. I'm an applications engineer here at Skyworks, and I'm going to talk about what Skyworks offers to access points, that make them better. So what do you want on your Wi-Fi access point? Typically, you want these four things. You want to cover the whole living space, so that's the range. You want a high data rates, ideally throughout as much of that coverage space as possible. And you want it typically to be small and not consume too much power. Now, what Skyworks offers is front-end modules and filters for these access points. So how does what Skyworks offers translate back to this? Well, let's start with the first two, range and throughput. So to achieve a good range, typically you want to transmit your signal at a high power. The higher power, the farther it'll go, the easier it'll be to be picked up further away. So that gives you your range, power. On this side, we've got better EVM. That really means you want a higher quality, a higher clarity, higher fidelity signal. And so the combination of these two really gives you the best access point experience. So you really want to maximize both axes to get the most area, if you imagine this as a rectangle. So in terms of the signal clarity, if we look over here, these are all the different modulation points, the symbols in the Wi-Fi signal. So without getting too complicated, notice these dots are extremely close together, very hard to distinguish from each other. That's why it's so important to have such a clear signal. You need those dots to be perceived clearly and not be mistaken for adjacent dots. So that's what we're showing here. We're achieving an EVM, error vector magnitude, of minus 41 dB. That really means we're hitting each of these dots with less than 1% error, so very precisely. And we're doing it at 18 dBm of power at the antenna. So that combination right there is really maximizing that rectangle that I talked about earlier. Now, what about reducing power and making it a small form factor, small AP? So right here, you'll notice there's a feedback signal. So we have our transmitter chip here sending the signal in. Here's the Skyworks power amplifier. And afterwards, there's an observation point. That transmitting chip can look at that signal and compare it. It knows what it wants to send, and it's looking at what it's actually getting out, and it can actually see the difference and compensate for that. Correct the signal going in to make up for distortions in the amplifier. That's called digital pre-distortion. What that does is it gives us actually a 15% savings in the power consumption of our FEMs without degrading the quality of our signal. So that's a 5-watt savings for kind of a typical sort of access point. And that's actually quite a lot. It allows the access point to be smaller, less expensive, and still offer a great experience that you're looking for. Finally, Skyworks offers filters. One of the things, so the filters are not only needed at standard configuration, but they can also be used to improve your spectral usage. So here in a typical access point, you would have one channel occupying each of these slices of spectrum. But if we add in filters, we can break up these pieces of spectrum and allow you then to add in more radios and have these pieces operate side by side. So really increasing the number of radios that are operating in your access point, greatly increasing your data rate as shown here. So that's, in short, what Skyworks does to make your access point a lot better. Thank you.